Hello student, it is our second class in mechanics. It is our second class in mechanics. Here I want to say something to you that you must watch all these video in an orderly manner, one after the other, in a proper sequence, so that you understand mechanics in a better way. And also try to find out the link when we are shifting from one chapter to another. And not only you watch all this video, you also try to note down what you listen in the class. And I want your sincere involvement in this attempt so that you grasp all those ideas in understanding the mechanics. In last class, we have talked much about the system of forces, then resultant force and state of a body. System of forces, resultant force and state of a body. That means there is a system of forces and you have to find its resultant force and what the resultant force creates on the state of a body. So what we have found there, suppose there is a body and you find the body always at rest. So whenever you see it, it is at rest. So from that you can draw a conclusion that resultant force on this body is 0. Resultant force on this body is 0 because its state is not going to change or its state is not changing. So resultant force on this body is 0. There is another body and you see it in motion. That means the body is in motion. So here what we can say about the resultant force. Here we are sure or we are certain that resultant force is 0. That is why its state is not changing. With confidence we can say yes, resultant force is 0 here. But here we see or we find the body in motion. So we cannot say whether the resultant force is 0 or not. The resultant force may be 0 or the resultant force may not be 0. We are not sure. Or with confidence we cannot say yes, resultant force is 0 or resultant force is not 0 while a body is in motion. So we have to observe its motion. For that we have to observe its motion. So observing its motion means we have to observe its velocity. And if we find that its velocity is not changing, velocity is not changing, its velocity is not changing. So in that case we can say resultant is 0. Resultant is 0. And if its velocity is changing, suppose its velocity is changing, velocity is changing, velocity is changing. So in that case, resultant is not equal to 0. So mark it as a vector. Resultant is not equal to 0. So while we see a body in motion, we have to be a little bit, or we have to be very careful in saying whether resultant is 0 or not. So in that case, we have to observe its velocity. If velocity is not changing, then we can say yes, resultant is 0. And if velocity is not changing, then resultant is not, velocity is changing, then resultant is not 0. And you know, velocity is a vector quantity. Velocity is a vector quantity. Velocity is a what quantity? Vector quantity. Velocity is a vector quantity. That means it has magnitude and direction. It has magnitude and direction. It has magnitude and direction, as velocity is a vector quantity. So we know a vector quantity changes when its magnitude changes, or its direction changes, or both magnitude and direction change. So when there is a change in magnitude, then there is a change in vector quantity. When there is change in direction, there is a change in vector quantity. And when there is change both in magnitude and direction, there is change in vector quantity. Suppose you see a body which is moving in a curve like this. You see a body which is moving in a curve like this. So when or as a body is moving in a curve, at each point the direction of motion is changing. At each point direction of the motion is changing. How? You know, at any point direction is along the tangent at that point. A body is moving in a curve, and at any point, at each point the body has velocity. At each point body has velocity. And what is the direction of that velocity? So direction of the velocity at that point is the direction of the tangent drawn to the curve at that point. Suppose the body is at A, so its direction of the velocity is in this direction. So the moment body comes to B, the direction will be in this direction, in this tangent direction. And here suppose body is at C, so direction will be in this, around the tangent here at point C. So here what we find? We find that at each point direction of the velocity is changing. So direction of the velocity changing means velocity is changing, because velocity is a vector quantity, and when direction of the vector quantity is changing, that means the vector quantity is changing. So velocity here, velocity is changing. Velocity is changing. Velocity is changing. So velocity changing means resultant is not equal to 0. Resultant is not equal to 0. So whenever you find a body moving in a curve, so we can say, or you can say, that resultant is not 0. Resultant is not 0 because velocity is changing, and velocity changing means motion of the body is changing, and when motion of the body is changing means resultant force on the body is not 0. So next, So here there is no need of finding its magnitude, because one point direction is changing. So direction is changing means velocity is changing. So you don't feel the need of finding its magnitude or magnitude of the velocity. Magnitude of the velocity. So suppose you find a body and that body moves in a fixed direction. In a fixed direction. Suppose that body moves in a fixed direction. It is not changing its direction but moving, changing its direction and moving in a fixed direction. So fixed direction means the path will be a straight line. Path will be a straight line. So at the point A, but there is a velocity, and what is direction of the velocity? Direction of velocity will be in this direction. At point B, there is also velocity, and its direction will be in the same direction. Here at point C also direction is in this way. So here direction is not changing. In case of ball, direction is changing at each point. So here direction is not changing. So we have to observe its what? Magnitude. So we have to see what is the magnitude of the velocity at point B, what is magnitude of the velocity at point what is magnitude of the velocity at point A, what is magnitude of the velocity at point B, what is magnitude of the velocity at point C. So we have to here look into the magnitude of the velocity, because direction is not changing at the, in this case. So if magnitude of the velocity is changing here, that means velocity is changing. So in that case we can say resultant is not zero, as magnitude of velocity is changing. As magnitude of the velocity is changing. So as magnitude of the velocity is changing, that means velocity changing, and as velocity changing, resultant will not be zero. And if magnitude is not changing, that means magnitude same everywhere, and direction is not changing. So as magnitude is not changing, direction is not changing, that means velocity is not changing. Velocity is not changing. So as velocity is not changing, that means resultant is zero. Resultant is zero. So this much of knowledge we have to acquire to see whether resultant is zero or resultant is not zero on a body while it is in motion. So we have to be very careful in studying the motion of the body to see whether resultant is zero or not. But here it is a very simple case, because the body is not what? Changing its state, which is of rest. So resultant is zero. So we can say this part of mechanics as statics. This is statics. And this part is your dynamics. This part is your dynamics. This is statics and this is your dynamics. So here there is two division of the mechanics, which is your statics and dynamics. So in statics we deal with a body which is always in which is always at rest. And in dynamics we deal with a body which is in motion. So now I hope you got an idea about statics and dynamics of the mechanics. So let us move to another situation. Suppose here it is your what? Ground. Suppose this is a ground. This is a ground, and here there are bodies. Suppose there is a body and its mass is 10 kg, and here this body has mass 30 kg, 50 kg, 100 kg, and suppose here this mass is 1 ton. 1 ton. This mass is 1 ton. And suppose I ask you to lift this body 1 by 1. So you can easily lift a body of mass 10 kg. Here also you can lift. Here also you can lift. So what you feel here? So as the masses of the bodies are going to increase, or as masses are getting bigger and bigger, you feel difficulties in lifting them. You feel difficulties in lifting them with the increase in their masses. So in case of 1 ton, suppose when you are lifting the body which has mass 1 ton, you cannot move this body even half of an inch, or less than also that. You cannot move this body. So you feel as if it is glued to the ground. जेमती एटा भूमि रे अठा रे लगी जाइछि, और as if it is welded to the ground. जेमती केही आपको जेमती कोन कर दैछथि, वेल्ड कर दैछथि ग्राउंड रे, सेति पय तमे आपको टिके भी कोन कर परनो उठेई पारु ना. You are feeling, or you feel much difficulty in lifting this body having mass 1 ton. So that means जेतेबे तमे आपको कोन करूछ उठेबा को चेष्टा करूछ by applying some force, you feel and you cannot lift it. That means something is there which is opposing you. या तो केही किछि गुडे अछि जे कि तमो कोन करूछि अपोज करूछि, सेति में तो तमे याकू कोन करि परनो लिफ्ट करी पारुनो. जदि याकू केही अपोज करंता नाही, सपोज nothing is opposing to your lifting, जदि तमे याकू उठे चाहछो तो याकू केही कोन करंता अपोज करंता नाही. सो आमे जानिछु जदि गोटे बॉडी रे सिंगल फोर्स एक्ट करे ताले से बॉडी रो कोन तो बॉडी रो स्टेट टा चेंज हेबो. When a single force acts on a body, and the body is bound to change its state, or the state of the body will change when a single force act on the body. So suppose कौनसी opposition है, suppose there is no opposition and you are applying a force F. So in that case you will be able to lift this one, because nobody is opposing you, no other forces are acting on the body. A single force that you are applying on the body is acting on the body. So with this single force you can lift a body of mass 1 ton also, if there is no other forces are acting on the body. But here you cannot lift it. That means some other forces are acting on this body, and those forces are opposing your lifting of the body. So say the force that force is the gravity. So that force is the gravity. That force is the gravity. That force is gravity. Or not? So now you understand that gravity is opposing you while you are going to lift this body of 1 ton. So is not gravity working here, or is not gravity present here? Here also there is gravity. So everywhere there is gravity. Here also gravity acting on this body, here, on this body and on this force. On all these bodies gravity is acting. But here the gravity, the magnitude of the gravity is less, so that you are able to lift this body of less mass or small masses. You are able to lift body of small masses because of the lesser amount of gravity. Gravity is everywhere. So in order to feel the significance of gravity, I am taking a example of body of mass 1 ton, because here you feel some difficulty. Whenever till you not feel some difficulty, you will not think about the situation. So here, why you can lift here, but why you cannot lift this one? So that difficulty will make you to think, what is the reason I lift this body and why I cannot lift this one? Understood? So from this we can say, yes, gravity is here. So as gravity is acting on this body, so that means gravity is acting on all this body. But as the magnitude of gravity is less here, we can easily lift the body. And what is gravity? Gravity is a kind of gravitational force. So gravity is a gravitational force. Gravity is a gravitational force. Gravity is a gravitational force. All gravitational force are not gravity, but gravity is a gravitational force. And you know about gravitational force. You know about what? Gravitational force. And what is gravitational force? That means in universe, so let it is universe. And you know, in universe, every particle attracts every other particle towards itself. Every particle attracts every other particle towards itself. Suppose there is a particle A here, and there is another particle B here, and both are in the universe. And by gravitational law, each particle attracts other particle towards itself. So in that way, A attracts B towards itself. And what B does? So B also attracts A towards itself. B also attracts A towards itself. So each is having force. On A there is one force, and B also there is one force. Suppose the force on A we can mark it as FA, and force on B we mark it as FB. Force on A is FA and force on B is FB. So these are the gravitational force on A due to B, and this FB is the gravitational force on B due to A. So magnitude of these two forces are same. Magnitude of the two forces are same. Suppose if it is 5 ton, so this is also 5 ton. Magnitude are same. But where is the difference? Difference is in the direction. You see, force on A is towards B and force on B is towards A. So difference is in the direction, but magnitude are same. Understood? So this is the gravitational force. Gravitational force on A and gravitational force on B. So suppose this is a universe, and there is a single particle here, and let name it as A. Only single particle is there in this universe. So as it is a single particle in the universe, there are no other particles present. So nobody is going to apply force, gravitational force on this single particle. That means this particle will not experience any force. It will not experience any force on it. So when there is no force, its state is not going to change. When there is no force, its state is not going to change, and there is also no need of our studying mechanics. There is no need of our studying what? Mechanics. Because mechanics is the study of force and the state of the body. How the force is going to change the state of the body. So as here there is no force on a single particle which is present in universe. So what we are going to study? So the question of mechanics is not arise here. We don't need the subject like mechanics when there is a single body in the universe. Understood now? So in this universe, every body attracts every other body towards itself. So that means whenever you find a body, on this body there is a system of forces acting on it, because beside that body other bodies are present in this universe. So here what we find? A is a particle, B is another particle. So there are two particles here. There are two particles. There are two particles present here. So there is a force on A, there is a force on B. So how many forces are acting on A? One force. And similarly on B there is one force. A is experiencing one force, B is also experiencing one force. So when there are two particles present in the universe, each experience one force. That means number of particles minus 1. Suppose there are three particles, A, B and C. Three particles present in the universe or in your system. So B will exert a force on A towards itself. C also exerts a force on A towards itself. So now A experiences two forces, one due to B, another due to C. So there are two forces acting on A. Similarly, B will experience a force from A, and B also experiences a force from C towards C. So B also experiences two forces. Similarly, C will experience a force from A, and it is experiencing a force from B. So C also experiences two forces acting on it. So when there are three forces in the universe or in the system, each experiencing two forces, that is 3 minus 1. 3 minus 1. Suppose there are n number of particles in a system. N number of particles in a system. So then how many forces they are going to experience? The number of forces acting on each particle is n minus 1. N minus 1. So whenever you see a body, the body is not free of what? Forces. Large number of forces are acting on this body, because the body is present in this universe, and in this universe there are large number of other bodies. So no body is free of what? Forces. No body is free of forces. Forces are acting on this body. No body is free of forces. Suppose you on your road you find a bricks. You find a bricks lying on the road. You find a bricks lying on the road. किंबा रास्तारे गला बेले तमे गोटे इटा रास्तारे पड़ुथिबार देखिलो. So you see this is a brick, and when you see around there are also other bodies. There are other bodies are also present. There are tree, there are other stones are there. There are, you find electric post, buildings, so and so. So that means all those bodies are applying forces on this brick, on these bricks. So bricks is having number of forces acting it from the bodies which is surrounding the bricks. So brick, this brick on it, the brick on it is having number of forces. Brick on it is having number of forces exerted by the bodies around it. Exerted by the bodies around it. You see, on these bricks, large number of forces are acting, as there are large number of other bodies all around the bricks. So that means you can say, and they are all are attracting these bricks towards them. So all these are attracting forces. All these are attracting forces on the bricks. And earth is also a body in the system of in the surrounding of this brick. So earth is also attracting the brick towards itself, towards the center of itself. Earth is also attracting, because earth is also second body to this brick. So that is the weight of the brick. That is the weight of the brick. The force exerted by the earth on the brick is taken as weight of the brick, as we mean what is weight. All other forces are acting. So here what we find? Here it is a system of forces. It is a system of forces which is acting on the brick. The system of forces which is acting on the brick. And what you find? Yes, you can say there is a system of forces which is acting on the body. So what is going to happen to the state of this brick? There is a system of forces, you cannot deny it. Yes, you have an idea, you know about the gravitational forces, and on this surrounding these bricks there is large number of other bodies, and all those bodies are applying what? Attractive force on the bricks. All these are attractive force on the bricks. Each body is trying to what? Pull the brick towards itself, or not? So as each is trying to pull the bricks towards itself, so from that we can say a system of forces is acting on this brick. And let us see what happens to the state of this brick. What happens to the state of this brick? So you find this brick on the road today. Next day also you find the brick on the same spot or on the same position, on the same point. Day after, tomorrow also you find. So whenever you see the brick, it is on the same position, and days are going by. So that means the state of the brick is not going to change. So as the state of the brick is not going to change, what you can say? The resultant force on this brick is 0. Resultant force on the brick is 0. Though large number of forces are acting on the brick. Large number of forces are acting on the brick, and resultant is 0. Resultant is 0 because state of the brick is not going to change. So this is the importance of the resultant. Large number of forces are acting, no doubt, but what is the resultant of those forces? If there is some resultant, the state of the body is going to change. If there is no resultant, state of the body is not going to change. So this is the case. Now you have have had a better idea. And let us move to the two particle system. Suppose this is your particle A and this is your particle B, and A is having an attractive force towards B by B, and B also having one attractive force on it towards B. You see, how many forces are acting on A? There is no other. There is no other body present in their surrounding, or in this universe there is only two particles, A and B. No other forces are acting. No other bodies are present. So there is no body around them, so they will not experience any force except the single force on them because of the other body which is present. So on A there is a single force, on B there is a single force. So here it is a single force on A, and B also there is a what? Single force on B. Single force. And you know, when a single force acts on a body, its state is bound to change, or state is going to change, or state must change when a single force acts on a body. So what happens? So that means body A starts moving towards B and B starts moving towards A, because on each there is a single force. So when they are moving towards each other, at one point they collide. At one point they collide. During the collision, again they apply a force on each other. So due to that, again they get separated. So the distance between, they move away from each other, but still there is an attractive force acting. So after moving certain distance, again they starts moving towards each other, then they collide, then they separate, then they collide, then they separate. So here collision and separation will go on when there are two particles present in the universe. Understood? So as there are single forces acting on each particle, their state is bound to change. So they starts moving towards each other. Suppose here there is a particle A, there is a particle B is here, and there is another particle C, and both are on a straight line. So you see, there are three particles. So each particle will experience two forces. So on A, there will be a force from B towards itself. So or not. So it is a force from B. So let us mark it as FB. It is a force from B on A. You see, there is another particle C is in its surrounding or in its environment. So C also applies a force on A towards itself. So let us name it as FC. FC. So how many forces are acting on A? F, B and FC. There are two forces acting on the body A. So on C, similarly, there will be one force from B. We name it as FB, and there is one force from A. We name it as FA. So there are two forces on C, and what on B? So on B there is a force from A. We name it as FA, and there is a force from C. We name it as FC. So each particle is having two forces acting on it. So you see, on A, these two forces are acting in the same direction. FB and FC both are acting on the same direction. Similarly, on B, these two forces FC and FA, they are acting in opposite direction. On C, the two forces FA and FB are acting in the same direction. They are acting on the same direction. So let us apply our common sense. You see, on A there are two forces, and these two forces are acting in the same direction. That means they are not opposing; they are supporting each other. Here also, these two forces are acting in the same direction. They are not opposing; they are what? Supporting each other. But here, in this case, these two forces are acting in opposite direction. That means they are opposing each other. They are opposing each other. So when they are opposing each other, they may cancel what? Effect of each other. They may cancel effect of each other. So there is possibility that the state of the body B may not change, or there is a possibility that resultant here will be 0. Resultant here will be 0, because there is a possibility, because these two forces are acting in opposite direction. But in the case of A and in the case of B, the resultant will not be 0. Resultant will not be what? 0, because the two forces are acting in the same direction. They are acting in the same direction. So with this much of common knowledge, we are going towards finding resultant of number of forces acting on a body. Resultant of number of forces acting on body.